Hello folks, thank you once again for joining me today. My name is John and people call me John K, but it's okay by me. So today I want to continue with my AI security engineering journey, and this today is the second day, and what I've built today is a bit different. It's a kind of build up on what I did the last time. The last time I introduced us to the concept of AI systems, the large language module, the context window concept, embeddings, and I was able to do a hands-on that, put everything together in a knowledge that will help any security engineer to learn and to build something, that can help him to understand how AI system works and thereby understanding the risk associated with it. Today, I'm taking it further. I have in front of me a kind of an architectural workflow that tests the two sides of building an AI system, the RAG side and the agent side. And in between the conversation that happens, the memory and everything is shared to make sure that tasks are completed, information are generated, and we move forward. So today, like I always say, it's not going to be, maybe I'm just giving you like academic literatures. No, it's going to be hands-on, but I just want you to understand what I'm about. I have all my code arranged in maybe Python or some shell script, but I'll be talking about them before I run those codes. So the first thing I want to do today is to pick my environment. The LangChain libraries that is needed to build a successful AI system is, if you look at my list here, these are the ones I'm using right now. So I have the LangChain itself, the core, the community edition, the OpenAI, the ChromeDB, and all of that. So what I want to do is that I want to start by installing this package. So that is the first thing I will do. So now I have this because my system I'm using it to build, so it's up to date. When you are building yours, you might have to wait sometimes for me to get this, libraries and toolings up. In my environment, it takes some time. But for you, for the first time, it might take some time. Don't worry. But for me, because some of them have been installed before, it takes a very quick succession for it to come up. So after that is done, after the installation is done, then we move to the next stage. So that we have our libraries, being installed, prepare the environment. The next thing I want to say, I want to give you an understanding of the whole idea, the project lifecycle and basis of what I want to build is to build a system where I can feed in cybersecurity programs and processes. Then at the end of the day, that it will be able to provide context from my cybersecurity grounded system. That is where cybersecurity information, resources are stored, and that will help the LLM to ground its information in such a way that it will be useful, or even perform some tasks using agentic stuff to deliver some. That is my objective. And in that objective, if you look at the architecture I showed earlier, the first thing I need to do is to find my environment, which we have done in previous video, and today I've installed the library for today's job. The next thing I want to do now is to do what I call document loading, because I said my objective is to load cybersecurity related PDFs, files, information, like NIST RMF, like NIST RMF, like some CVE databases, like MITRE attack documentations. I just want to load all these resources in a place that it will help us to achieve some security functions and pipeline. So that is what I'm doing. So the first thing I'm going to do is to load that document into the memory of our system, of my system. Then the second thing is chunking. Is a process called chunking in AI. Now, this chunking is splitting that file into smaller pieces, because LLM has a way it shouldn't have access to that information. So the workings require that the chunking is done, splitting into smaller pieces. Then the third thing that we do is embedding. We know what embedding does. Embedding is also assigning some numbers into those chunks, so that those numbers are numbers that at the end of the day will be used to put those information together at processing time. So the next step is to store those embeddings in VectorDB database, and here I'll be using Chrome database. So after that, then after the RAS system, then I will build a UI, because sometimes you don't want to use CLI all the time. You just want to build a UI system, just for you to be able to do whatever you want to do. The last but not the least here is the agentic itself. You see, the agent that we build, that we created, or I created, working. So that will be my objective for this particular project. Now we will get into that, and so this is a script. So I have a globe pattern here, and before I go further, is that I have all the 3 documents I want to ingest into this system. I want it to be MITRE attack framework mappings. Then I included a NIST RMF. Then I included a OWASP top 10 for LLMs. So those are the 3 PDFs, and I have those PDFs stored in some of the directories here. If you look at the directory called here, it's called docs. So these are the 3 files. These are the 3 PDF files. So now I run that command, and when the loading is completed, we'll continue from there. So now if you look at it, the loading was done successfully here. It's done and correct by 95%. So we have some errors, like maybe 5% of the loading was not successful. It's not a big problem. This is a good loading. So that being said, the next thing I want to go for now is chunking. So chunking, if you look at my file here, you will see that I have you can see my chunk size. Some is 100, and I think the overlapping is 200. So this is how to chunk. It's meant to, like I said, it means to break down the system. It's meant to break down the files into smaller pieces. So I will move ahead. I will go ahead now, and yes, and if it's taking too long time, we'll meet at the end of the chunking. So if you look at the output of the chunking, you will see that it talks about rate tolerance here, talks about valid and reliable. So this is to show you that chunking is breaking that document into smaller chunks for, I think, easier access. So I just want to show you can see that if you look at some of the keywords that we have here, they are something that we are familiar with. If you read the RMF, that is a risk management framework, AI risk management framework by NIST, you see most of these words there. But it really didn't make much sense. So that is how it works. And with that shows that we completed chunking, and we can move to the next level. So like I said, we were 95% successful. And these are the errors that return maybe for the rest of the 5%. But to check, this is the 3 documents I loaded, and now the chunking, been worked on it, on the 3 of them. So you can see we have NIST AI RMF framework here. We have the MITRE pins, it says 2 pages, and this one is 45 pages. And so total percentage of pages across the 3 PDF is 95. So I'm just showing you that the system that I'm building is actually do what is expected to do. It is actually doing that. So it's a separate script that I wrote to check, but that comes very handy for us to be able to say, okay, are we moving in the right direction? Yes. So we have, this is my bed file. So you can see that we have like 3 library here that needs to be imported. All of them I've installed them in the first place when I started this lab. So the globe here kind of point to the location, the direct location to where those files, those PDF files are. And there's other things that I wanted to pay attention to is the splitter here and some of the information about the chunks. So these are the informations that we need. And when that is done, I run my script. Let's see what we got. By now we should understand what embedding does. So yeah, so I think we are good. So now we have it's telling us that the total chunk is 256, and then after this is done, we can move to the next stage, which is within the Chrome DB, which is our vector database. Now at this point, what is going on is that whatever we've been doing from document loading to embeddings, they are happening whether between my local file and my local memory. But at Chrome DB or vector DB level, we are finally having a place where we can store those vector numbers and embed, where we can store them for later use. If I'm out of this session, I will not lose those things. So this might take some time, and then when it's completed or it's complete, we'll get back to it. So that was a quick one there. So we can see now that the DB is saved in this location, and everything looks fine for the DB now. So the next step is going to be how to build RAG. So now most of the things we have done now is to prepare our environment. Now the real show wants to start. It's like the real application, AI application we want to build. This is where it all kind of accumulate and compound. So at the end of the day, I just want us to take a bit of attention while I do that. Okay, so like I said, the embeddings, we call them embedding vectors. So because when a document is splitted or broken down into smaller chunks. Now, when that chunk is broken down, like I mentioned, the first thing that got attached to it is what? Like token ID. Embeddings doesn't like to relate, with text. So it assigned it a token ID. So embeddings now work with the token ID to produce what I call embedding vectors. So the embedding vectors are now stored in vector databases. Now, when that happens, the next phase is what I call RAG. Is what is called RAG. So the job of the RAG, like the name implies, is to retrieve data from a proprietary source, like vector databases like that within your systems, and use those information, bring it back to the LLM prompt, so that the LLM prompt, the LLM itself, can use that specific information that is proprietary or not public and use it with other information, maybe public, and ground the information and make it not just very unique and very specific for a task. So what are we doing now is, if you look at it like my screen now, you will see my RAG script. So this is my RAG script, and you can build one for yourself. It's very easy to do that if you know what exactly you want to build. So if I do Python or RAG pi, so let me see how long it's going to build. So now my RAG system is up and running. And for instance, if I want to test whether this is working or not, I can ask it to say where is Mars. So let's see whether it will be able to answer that question. Where is Mars? So sometimes because of resources, my model might take some time because it's local. So I just want you to bear with me, and I can pause the video and get back to it when it comes back. So hello everyone. So it takes a while for me to get the output back. If you remember when I asked the question after the building of the RAG system. Now what that means is that everything I'm going to do right now, every question I'm going to ask the RAG system is going to be based on the 3 documentation I uploaded in the docs that eventually got embedded into the vector database. So the point here is that when I ask that question, where is Mars? Now look at the answer the RAG system was able to produce and send back to the LLM itself. So it says, I don't know based on the provided context. The provided context does not mention Mars or any related information about it. This is perfect. This is a well-grounded and well-guarded output, because what the RAG system should do is to prevent the LLM from splitting out anything outside of what is within the RAG system, which is the context. So this is a very good information. If I ask another question like, list me the top 10 LLMs, or let me say top 10 for LLM, this is going to take a lot of time for it to come back, but eventually it will come, and you will see that it will respond positively to this, because this information is provided for and can be found within our context environment, which is our vector DB. So let me give it a shot and take some time. Okay, sorry. So RAG, and I will say, let's give it some time. Okay, so list 5 out of the over 10. So let me give this a shot. It will take some time, but I'll wait for it and we'll come back to that. Just for us to understand that whatever we embedded within our vector DB will be what will be provided as a context for the LLM to produce its output. So the way it works, that is the way it works. So folks, so if you look at my screen right now, you will see that eventually we have this up here. So in the previous, before now, I asked it for a particular answer that where is mass, and the response we got was that context, that information is not provided in the context, meaning that it's not within our RAG system. Now, because I have a top 10 for LLMs risk in the embedding, now if you look at it now, it was able to show us like 3 of the embeddings here. You see it here? So you can see that we have sensitive information disclosure, data and model poisoning, supply chain risk. These are real risk within that documentation. And this is to show us that whatever we have within our RAG system will eventually be used by the LLM, as a context when grounding the final output of our questions and our queries against the LLM. So the other thing I want us to look into is the UI I was talking about, that we can actually build a UI for our RAG system so that at the end of the day, we don't have to interact with CLI all the time. So I have the script here and I can run that, and let's see what we got. If we don't have it automatically popped up, we have to pause it. And so folks, so when I build there is a tooling called Streamlit. So that was what I used to call it here. If you look at it, you see it here, Streamlit. Run API. It just provide kind of like a CSS, HTML UI for your application. When a Python application, it can just provide like a default UI for it to work. So that is what I did here. So I used that to run it, and if you look at here, you will see this is the interface. So instead of me now, if I want to supply more information into the RAG system, instead of going to the script and modify the docs content and stuff like that, from here I can actually add some PDF files. I can add some PDF files. So this is what it takes to build a kind of baseline for your chat application, for your agent and stuff like that. So with that is completed, and I think there is a thing I prepared, which maybe the last for this particular. I know we can build and everything we have been building, but at least there must be a place where I get to make sure that I'll be able to complete the circle. And I think the last one is a security agent itself. So let me get into that. Hello. So when I tested my security agent, if you look at my script here, you will see that I was actually calling VirusTotal API, and I was actually calling a vulnerability database endpoint and MITRE attack endpoint as well. So I want this agent to call these 3 resources, and when I ask questions that pertains to them, I want that agent to call these three endpoints and be able to give me result. So if you look at the response is cool. It says, I am happy to help. However, I must clarify that since the two resulted show number of CVE found, it means there is no non-publicly disclosed vulnerability with the identifier Ds. In other words, the CVE doesn't exist. So you can see now it was able to try to look it up, but because I just put some fictitious number there and it couldn't bring in something substantial, but it shows that it's calling those endpoints when I ask it to make sure that, okay, can I get this question from this endpoint? Can I correlate them? Can I do what I'm required to do as an agent? And that is what I just want to show us. So this is like a full circle. In this particular lab today, or this project today, I have shown how to load document. I have shown how to build an agent. I have another agent, but it's just like almost the same thing as this. I deliberately, take this as an example, the one of a security agent, where we can have an agent that help us, look up some information from VirusTotal, look up some information from a vulnerability database, look up some and map it to MITRE attack. It's more or less like what every security practitioner does, maybe at SOC operation level or for some other reasons. So this is a full circle, and I hope that this benefit whoever is watching this. Watching this. Thank you. Okay, so this is another example. If you look at this, I ask it about this particular vulnerability, CV 999-0095, and it says CVE blah blah is a vulnerability in the Microsoft Internet Explorer. These are old school vulnerabilities, but I'm just testing with different vulnerabilities, with different CVEs to be able to see how well this particular agent is doing. Yeah, so I might be able to show another example before I wrap up this video.